right, cool. Looks like we actually got live. Sweet, sweet. Now that we turn on the lights. What is up, people? All right. Let's see what we got today. Google Online SRE books. Yeah. Site reliability workbook. Why is there a workbook? SRE. Yeah, this I actually have not gotten into reading this one. I've only read the software engineering at Google. Actually, funny enough. So actually, the two I've read actually are software engineering at Google. Is this one, by Hiram Wright. This was actually pretty good. This one's pretty much the technical know-how of how things actually work at Google. I can't really speak to whether or not that's actually true, but you know, if like if the staff software engineer is writing books with the endorsement of a bunch of other engineers at Google, I think it's pretty good. And then the other one I think I would recommend is actually in the Plex. How Google Thinks Works and Shapes Our Lives. It's by Stephen Levy. And it's basically a recount of all the engineering efforts and events that led to Google as we know it today. So it takes you into like basically the creation of Google, the competitors in the early days of search, and then how they eventually monetized it with like AdWords and AdSense. And it's actually pretty cool. I think the whole once you understand the history of it, you actually begin to understand like where Google's culture comes from and how they were able to essentially grow their business. And I think that culture pretty much exists today in some form or another. So if you can actually connect basically these two books, actually, you see the history of how Google is built and Google's economics. You eventually understand where all these practices actually come from. It's actually quite fascinating. So I'll give you an example. So let me see if I can think of an example off the top of my head. Actually, there's one that I remember distinctly reading. Um, shit. Yeah. So it's the whole effort about like actually monetizing Google actually. So one of the things they actually really focused on wasn't actually the monetization. It was actually the quality of the search. And I thought that was actually pretty interesting because they always made it an effort. Larry Page and Sergey Brin always made the effort to make sure that the advertisements served the search results. And one of the statistics that was really interesting that popped up was when they polled people about the advertisements that they had, and then people automatically said, "Wait, what advertisements?" And turns out the way they had structured it was that the advertisements were in service of the search results, and the way they did this was basically through some algorithmic bullshittery, let's say, or manipulation, where it would try to match the relevant results to the advertisement. So if someone had, like, say, a there's a keyword like for hand lotion, right? Someone has artisanal hand lotions that they sell in a magazine, and someone else has a travel website that, and then they try to use the hand lotion word in order to hit that. Well, Google has this thing of actually being able to figure out whether or not the guy trying to manipulate the search results for his travel website is actually doing it versus someone who actually genuinely is selling a good hand lotion. And so because of that, they actually rank the ads by that order. And most people only really take a look at the first page and the top, three ads and search results. And so the point here is that whenever you try to build something, it's always the core product first, and then everything else after that serves should be prioritized in service of that. And so one engineering practice I think they have is basically like this idea of documentation. Is that at least the way I understand it is that they write code and they also treat documentation that supports it almost as good in service of that code, but they also treat it as code itself, where it needs to be retired, it needs to be maintained. It basically is treated alongside what is prioritized. So I think that was a pretty interesting connection. Anyway, let's bring my client on. Let's chat with him. Hello?
Hello.
Hey, what's up?
Doing good. How about you?
Hey, doing good, doing good. Yeah, I actually just got home from SF, so yeah. So let me know like what has been going on in your world. How has practice been?
hmm Yeah. I actually haven't started the tag in Microsoft questions. I
Nope.
just practice. Hello, can you hear me?
Yeah, I can hear you.
Yeah. I haven't started like the tag in Microsoft questions. because there was few graph problems that was still not so confident, right? So I decided to study this
Okay.
because I had like a little bit of hard time for those specific graph questions. And yeah, today I had a assignment for today midnight. That is exactly this time here in Brazil,
Okay.
and I work on this Friday.
Okay.
So that's pretty much it. But on the weekend, I'll be like full on practice.
Okay. So you
That's
haven't
pretty
really
much it.
done much since our last meeting.
Yeah, yeah.
Okay, that's fine. Yeah.
I
So
have one question
yeah, go ahead.
as well about practice.
Yes.
In terms of like behavioral, like do you recommend me to like just read back like those notes or anything else related to practice?
Yeah. Essentially, remember the when we talked about the behavioral interview, it should be presented in a way that anyone, even with a non-technical background, can understand the importance of what you did. It's the
Yep.
exact same thing. I want you to really practice that, making sure that your delivery for explanations, for stories, is short. It is like short, sweet, to the point, and can easily be delved into. That you make it sexy. You make it like the interviewer wanting to know more without boring the fuck out of them. And so
Just
I
this
recommend,
sparkling.
huh?
Just this sparkling, I think the term you use, right?
Sure, that's one way to put it. I like to say make it sexy because
Mhm.
it's a lot more like in your head. Like, the litmus test is always if someone else has the similar
Mhm.
experience to you, what
Yeah.
makes you stand out versus that other guy? So, for instance, if I compare two people at Google, both of them have worked
Okay.
on products, right?
Uh-huh.
What makes one guy stand out over the other? That's going to be really important. So, for instance, and I'm going to invent this out of thin air, right? Let's say one
Cool.
candidate says, I worked under my tech lead and delivered products that increased user engagement behavior by 3% on YouTube ads, generating $400,000 of additional revenue per quarter for Google. You know, I'm to be like,
Yeah.
okay, that's great, that's business, right?
Yeah.
But then let's say someone else says, oh, I worked on a product under my tech lead at Google where you know, um, where I modified the structure of our comment section to do A/B testing, so that and eventually that new format over, you know, that new format we eventually turned it on and increased to user engagement by 7%. For the user. Now that sounds like very, very different. That sounds like very similar, right? One guy saying, "Oh yeah, I
Yeah.
increased ad engagement." The second one says, "Oh yeah, I did some A/B testing that increased person engagement." But I'm more inclined to take a little bit more interest in the second person's experience. Do you know why?
Oh, thought was the first because the first talk about like figures, like about money,
Yes.
you know,
Okay.
and the second one talk about more implementation and like A/B tests and all
Mm-hmm.
and this stuff. I was kind of like yeah confused
Yes, you're gonna
because
get.
I guess the first one is more impactful, like four thousand dollars, four
Mhm.
thousand, yeah, a quarter, right? I think that's a good number to
Sure,
say. I don't know.
sure. And don't get me wrong, everyone has this problem. And numbers
Uh-huh.
is one way to show the impact. Yes, but when it comes down to being interviewed as an engineer, it's a completely
Uh-huh.
different ballgame. It's like I don't care how much money you make the company if all you had to do was switch a flag. You know, you could say you let's say you made Microsoft $1 billion, and all you did was change the color of the logo. Now, is that
Uh-huh.
interesting to you as an engineer?
Not at all.
But it's the same thing, right? You just judged it based on the end number. And the guy
Yeah,
made a
you're
billion
right.
dollars for Microsoft, which is like 1% of their like annual revenue, which is pretty fucking massive.
Yeah,
So you get my
but
point.
that's not interesting.
It's
That's
not
not
interesting.
interesting.
Exactly. It's that the number just says, hey, your work was important in some way, but
Uh-huh.
when after a certain point, the magnitude of the engineering effort and the complexity of it and how much of it you were
Mm,
able to actually execute on is going to be the difference. And so, like for instance,
nice.
it's being able to understand how hard a problem is and how you're able to navigate it. Another example, I guess, would be winning a chess. Like let's say chess, right? Let's say you
Yeah.
won a national champ. Let's say you won a national tournament, right, for the under 16s, and you won
Yeah,
ten
yeah.
thousand dollars. The second one
Uh-huh.
is you played 6 games against Carl Magnuson, the world champion, and you went 3-3. Which one is more interesting?
Oh, I guess the second one.
Why?
Because like uh, my point of view, this guy is like the reference, right? In chess, probably,
Mm-hmm.
or champion.
Yeah.
So no, yeah, but you haven't won. You just played,
Mm-hmm.
right? I think, yeah, going to this perspective, the first one you won the entire tournament. I think it's more impactful the first one actually.
Mm-hmm.
Just analyzing more in depth. I think the
Mm-hmm.
first one actually.
Sure, and that depends on your
Yeah.
audience, right? If you're talking to like a general audience who knows nothing about chess, they're gonna think, "Holy shit, you did this amazing thing, and you have and you have a title for the U.S., right?" But I would
Yeah,
argue
that's right.
someone who is more seasoned in chess and who has kind of been
Hmm.
down that road, who understands like what chess actually means, is more interested in the second one. It's like, okay, well, how'd you do against Magnus Carlsen? What was the game like? Why did you go 3-3? Why didn't you win the fourth game? You know, and so it's being able to appreciate the technical details. It's like, maybe you did a King's Gambit in the fourth game instead of a Sicilian defense or something like that. And then the person will be
Uh,
able to have that conversation with you, asking, why did you choose this? What did the previous 3 games insight give you that made you want to do that? Whereas someone who has no clue about chess would not be able to talk about that at all and has no
I
fucking
see.
idea, right? It's about the appreciation of nuance and who you're talking to.
I see.
Yeah. And so,
And for engineering perspective, it's like the challenge is more. I think it's more appealing to talk, right?
there you go.
The challenge of the engineering, right?
Ding, ding, ding. There you go. Because the people you're talking to are probably easily L4 or L5 engineers who have been
Uh-huh.
down the road, who understand, okay, this is what the engineering process is like, and we need someone who can fit that, right? And so,
I
because of
see.
that, we want to see someone who has taken on projects that
Mhm.
reflect that complexity, that reflect the ability to take on that challenge. And very often, these complexities correlate to results, right? And
Yep.
so that's why it's kind of easy to put things in numbers because it gets your foot through the door. But when it comes down to it, and when you actually need to talk about it, you really need to
Uh,
be able to describe the complexity and the process that you went through in order to get those results. That's what the meat of the talk is going to be when it comes to the behavioral interview.
oh, great.
Do you remember what I said
Oh,
about the matching the engineering ladder expectations?
yes, yes, I remember.
That's where that actually becomes relevant. It's like, okay, well, we're gonna judge you based on these criteria, right? Your junior engineer,
Hmm.
senior engineer, whatever, and we have like an internal rubric to make sure that you can handle that. And
Hmm.
so
Yeah.
saying something like, "Oh, I just changed the color of the logo, pushed it out, and then got $1 billion," well, that's not like interesting. That's not like relevant to any of our
Yeah.
engineering perspectives or the way we grade engineers. But good job
Uh-huh.
on getting the company an extra $1 billion.
Yeah, but it's more like a design, right? Nothing related to engineering. Yep,
Right. It's like if
that's correct.
it's just that there happens to be a correlation between the complexity of work and the result and the financial numbers in a lot of cases, but don't take it as correlation and causation.
Okay, no, that makes total sense.
Yes.
I remember actually in one stream you showed like I think was one PDF, one chart
Yes.
that shows like what to expect from L3, L4 level, right?
Hmm.
And I think was pretty clear like to see.
Yes.
It's more related to this that you're saying now.
Correct. That's the Square Engineering ladder. Let me actually bring that up.
Hmm.
So I'm always go. It's the first link, the Square's growth framework.
Square's growth.
That they took it out of the Google Sheets, and then they moved it to a PDF. So here, I'll send you the link.
Okay. I'm watching on the stream as well.
Oh, okay, cool, cool, cool.
Yeah.
Yeah, so you can see like the L3 engineers acquire the skills, knowledge, and expertise necessary to meet the expectations of blah blah blah. Writes, debugs, and documents code according to standards and practices. Debugs, participates in software design and features and bug fixes. Serves as first call, blah blah blah. Mostly, it's going to be looking at can you design software small features and do bug fixes and debug things, right? And I'm always
Yeah.
and the way I want you to do it is like do this, make sure you hit all these, but
Mhm.
also sprinkle in a little bit of this, where you can design, ship, develop, and ship features. And then you could also what's it called enhance the code structure and test coverage of what you got going, and then implement code that is clear, concise, and easily understood by others, and that you're responsible for the lifecycle of the code. This one especially, the lifecycle of the code, development, test, and production. I want you to see a little bit
Oh,
of this as well, just so we can lock it in. So
I'm seeing. Yeah.
yes,
And all of those like criterias, they can be taken from a code interview. Like you can evaluate all of those aspects.
I can tell
Pretty
you, yes,
interesting.
easily within the first 10 minutes, I already know whether or not what level the guy is, and then whether or not, and then the next 40 minutes is just eking out and making sure I check off each one of these boxes.
Oh, I see. That's
It,
pretty interesting.
yes, it's real recognizes real. I can tell you, there's been a
Uh,
lot of times where people have tried to fake their way through an interview, and I almost always catch them in the first 10 minutes. I have never had someone get past that.
whoa.
I mean, then again, you got to give me credit. You know, it's 6 to 8 years of experience. I've interviewed people at like L5 level,
Uh-huh.
so
Yeah,
I
for
can catch
sure.
people like pretty easily at the L3 and L4 as well.
Uh-huh. Uh-huh. Just one extra point here. Like on the meeting prep of Microsoft, one
Yes.
thing that they said that I kept thinking is that I'm gonna have three interviews, three 45 minutes interview,
Uh huh.
and they were saying that like he didn't mention like the quantity, like the number of interviews,
Okay.
but some interviews are gonna be more focused on like how your thought process.
Yep.
Some interviews is going to be pretty focused on the code itself, if there's any bugs or any like huge mistakes, you know.
Yep.
And but some interviews are going to be more focused on like the engineering aspect,
Yep.
like this discussion, this engineering discussion. And he even said like for this one in specific, I'm going to ask you one question just to fill the time, you know, just to fill up the time.
Yep.
We can have more, but I would be pretty focused on like what you're saying about engineering, you know.
Mm-hmm.
So better be aware of this as well.
Yeah, I'm going to tell you that it doesn't, like, all that is bullshit because the process doesn't change, right? They're going to say, oh, we're going to grade you more heavily on the code. Well, where does the code come from? Having clean thoughts and
Yeah.
clean execution, right? You have that clean execution,
Yeah.
you will get bug-free code. So, and the other guy says, oh, I will just focus on your approach to the code. Like, well, you're going to be doing that anyway to get the clean code.
Yeah, yeah,
So,
it's intrinsic. Yeah.
exactly. It's just like that same process. That's why we do what we do, and that's why I give you one process to get really really perfect because all that will come naturally. So
Yeah, yeah.
as long as you have the clean thoughts, as long as you think precisely, and that you can set yourself up for success, the clean code will come.
Uh-huh. Yep.
So
You're
don't worry
right.
about that. The last thing it's just that the behavioral one that you are going to need to have some extra help with, and we could do that on Tuesday or even today if we have time. But I want to give you this. I really want to do like a actual like off the cuff interview that you may not have necessarily prepared for. But I want to see how well this works because I think it's going to be pretty similar to some of the questions that you might face. Does that make sense?
Good. Good. Yeah,
Cool, cool, cool.
yeah. Okay.
Actually, give me like a minute or two. I need to get some water because I kind of just like rambled my ass off for a hot second.
Oh, don't worry. Go ahead.
Yeah, yeah. Okay, I'm back. Cool. You still there?
I'm still here.
Great, great, great. Okay, cool. So let me bust open the timer, and then we'll get started. Okay,
Problem
I'm on
sheet
your prep
M,
doc.
right?
Huh?
Problem sheet M or
Uh,
prep doc?
actually, yeah. Let me get the problem sheet M out. Hold up.
I have the link if you.
Give me like 10 seconds. There we go. Problem sheet M. There we go. Cool. I'm on it. Are you on it?
Oh yeah. First page.
Cool. All right. Let me get the timer out. All right, and then here we go. So, the question I want to give you. Oh, it did a page break, right? So, I want you to create a image caching library. So, what does this mean? So what I mean by this is that whenever we go and retrieve images, like let's say we are a web server or something, right? And we want to go and display images to the end user. Now, these images may be sourced from other websites. So, for instance, maybe we want to display a picture of a fish, but maybe it's sourced from Pinterest, and then maybe a picture of another fish, maybe sourced from National Geographic's website, right? And so it'd be kind of a pain in the ass to just keep hitting those websites. So, given that, and given that many other developers may be using this, I want you to develop an image caching image caching library for them to use. Does this make sense?
Yeah, it makes sense.
Okay.
Like the pain. Just repeating here, like the pain is that you don't want to be hitting those websites all the time, right?
That's gonna be that's one of them. Keep in mind, there can be plenty of stuff.
Okay,
and I want you to design it, and I want you to design the API for it and how it might work underneath the hood.
Okay. Okay. So the first thing I can think of is that we we can have access to one image. Like imagine one link, link 1, and link 2. Just my line of thought here.
Sure.
But we can, since it's a caching system, right? I was wondering if we can use a kind of a sort of timestamp just to know like how often those links have been used, because the older they get, we're gonna discard, we're gonna delete them. That's what I was thinking, like in my first thoughts.
No, okay, that's good. That's a good one. For now, let's assume that the sources are static. Let's assume that even if it's like 30 days, 60 days, 9 days, that the original sources don't change. Let's keep it simple for now.
Original source doesn't change.
Right. So assume that you don't have to do any that the image based on its age doesn't change.
Oh, I see. So the timestamp doesn't matter, right?
If you get an image of interest today versus like 90 days from now, assume that it'll be the exact same image and the image will still be there, just for now.
Okay. And one question, like this caching, does it have like a size? Like I can store like 100 links or because I was wondering about this as well.
Okay. Yeah, another good question. Let's say that you can limit it by M number for now. Just M being some arbitrarily large number.
Okay. All right. Okay, so like, so the size of the caching is going to be limited by this M number. But like, one problem that we're going to have here is that in this caching, we need to retrieve the images, like to get the images.
Yep.
So we need to be aware of like the get images, right?
Sure.
And like, actually, another thing is to insert a new link to this, just like an API, just a normal API. Insert images and what else? And yeah. Oh, actually, delete. One thing that I was thinking is when we hit this M number of links, right?
Yep.
We need to have some criteria to eliminate, to delete
Yes.
the links. So that's what I was thinking
Okay.
as well. Like, so, what's the proper word for this? Like, yeah, when hit the limit of the cache, select delete. So those are some problems that we have here.
So yeah, you're talking about an eviction policy.
What is the name of it?
Eviction policy. So it's basically it's just a word to describe exactly what you just said.
Yeah, I didn't use this word.
It's
yeah.
fine. But you described exactly
Okay.
what you needed to do.
Nice. So cool. I think those are like the main things we need to be aware of in this caching library. All right.
Sure.
Yeah. And whenever like let's say another system wants to hit a link, to access a link, it's gonna access the get method of this API, and then yeah, and if it's not in the if we try to get a image that is not in the caching library, we need to retrieve from another website and then store inside of this cache.
Sure.
So the flow of things for this get can start like this. So let me just take notes of that.
Okay. I see what you're doing. Let's do this. So you're right. That we may or may not actually assume that get image doesn't actually do the HTTP request. Assume that's going to be handled by someone else. So for instance, all we want to do is get, insert, and delete images from this cache.
Great.
So ignore the case where you have to do a request.
Okay.
Assume that's handled by someone else.
Okay. So for the get image, like the first thing I can think of is we can have some sort of list or array.
Okay.
Defined by the M number, all right, of arbitrary number we chose, and like the most naive thing I can think of is like traverse one by one inside of like this list or array, and then whenever we found the image that we want in this get, we're going to return like the link. Or actually the image.
Hold on.
Yeah, one question. Do you want me to return like the link for the image or like the image itself?
So that's the thing. What is your input? What is your output? What do you think a user of your library or of your structure would supply you?
Since you mentioned that the user might want to access some websites, all right?
Right.
I was wondering that the inputs, like defining the inputs and the outputs, the inputs are going to be the link, specific link for the image. Specific link for the image, and like the output, actually the like one thing the first thing that comes into my mind is not the link for the site, because it's going to be redundant to have this caching library, but another link, for example, a S3 link, where I stored on the S3 bucket, like my images, on this caching.
I think that's fair.
That makes sense for you?
I think that makes sense. Yeah. So you're right. On some level, you have to manage the like the uploads of the copy of the file. So I think what you're talking about is perfectly fine.
Okay. S3. Okay, so we just defined the inputs and the outputs here. Like as I mentioned, for the insert images, the insert images method, it's going to be pretty attached to the image, to the get images, because, for example, is that other case I just talked before. Whenever we try to get one image, one link that is not into our library of stored images, of caching images, we need to like retrieve this from the original website and then store into this external
Sure.
external
but like
bucket.
I said, assume that kind of logic is going to be handled in your insert, because you have this API get, insert, and delete image, right?
Yeah.
So then what exactly? So when you insert, what exactly would you be inserting?
I'll be inserting the link.
Okay.
The link itself.
The link
Yeah.
itself. Okay.
The link for like where we storing the cache.
Sure.
You know.
Okay.
What I was thinking.
Okay. So
and yeah, so go ahead.
I was gonna say, okay, so it seems like you have an idea of how that you want to structure this.
Yeah.
Okay.
Okay, so yeah, as I mentioned, like on before define the inputs and outputs, the get can be linear, right? So we can scan through a list of links,
Okay.
which is going to be like pretty inefficient because we can have like 1 million of links and it's going to be pretty inefficient, all of n in time. But like we can, every time we insert a link, right, on this list of links, and sort it, and we can have a sorted list and perform a search into those links in all of log n time, right? Just doing a normal binary search. Suppose that we kind of we have some policy to create the names, so we can search them or by numbers or like some structure kind of names when creating those S3 buckets as S3 links.
But that's not efficient at all, because you want this to be fast. So then what is there something better?
It's not going to be efficient because like for every time we're going to sort, let's say in Python we are using the sort method, it's going to be n log n time, and it's not going to be efficient. One thing that I was thinking, like to be more efficient, right, in the insert and the get images, is maybe have some sort of a hash map.
Okay.
But I'm just because it's gonna give us like the access time of all of one.
Sure.
Right. And the delete, depending, I just need to structure this more. All of one, but in case that there's like collisions, it's gonna be all of n, right? In which the n is gonna be like the links that are collided in the hash map.
Okay.
And this also applies for the get and also the insert. Okay. But the average case is gonna be all of one.
Sure. Okay.
So yeah, so
I want
those are the points.
Okay, so I want you to actually implement all what you just said. So suppose I have a class image cache, right?
Yep.
So I want you to go ahead and implement those functions that you described and make sure it all works for now. Okay?
Is it okay if I do this in Python?
Yeah, go ahead. I just wrote it in Java out of habit, so do that.
No worries. Okay, so yeah, so the first thing we need to do is like we need to define our structures that we're gonna handle this. So for this, I'm gonna create this constructor here. So every time it's a autocorrect.
Don't worry about it. I understand what you're trying to do here.
Yeah. So whenever we instantiate this image cache, we're gonna have this let me think here. Here's the thing: we can have the array or the hash map. So since I was saying that we can have, yeah, we can basically have a hash map where we're gonna map like the link that some external system that you said, right? That's
Yeah.
gonna do this S3 conversion for the link to the S3 here. So we're gonna have here our hash map. And what else? And yeah, so and now we're gonna have another method that is the get image. We're gonna have and receive the link. Okay, so basically this hash map is gonna map the link that we received to the actual link for the S3 bucket.
Sure.
That is our cache. And yeah.
Okay.
For the get image, the first thing I'm thinking of is just verify if the link is on the hash map. Like just thinking what I need to do here. I need to verify. Oh yeah. Verify if it's not there. If not in the hash map, I need to. Is it okay if I just abstract like some create link function to do this sort of operations?
Yeah, go ahead.
Okay. If not in the hash map, create. Actually create. Actually store the link, the image on S3 bucket.
Okay.
And get its link. Okay. If is on the hash map, I just need to return the S3 link.
Okay, so I want to clarify this. If it's not in the hash map, assume that the S3 bucket stuff is handled somewhere else.
Yeah.
So that
That's what I was trying to say.
Okay, so that what I would say is don't assume that you have access to that function. Assume that if you don't have like you can't add an image into it unless someone else calls that. So if that's the case, then what do you think a fair response would be in this case?
Someone. Okay, you're saying that someone else is gonna handle this.
Yes.
And if I try to access an image that is not in the S3 bucket, what I say since the beginning is that I will try to add this there.
And I'm saying you can't do that. I'm saying that if you do not have an image in the hash map, what do you think is a good response?
I will return null because there's nothing.
Yeah, because you can't do anything about it. You can't. I told you cannot access the image. So.
Okay, so yeah, then I'll return null. Oh yeah, it's pretty like trivial. Like yeah, if link not in hash map, I'll just going to return none. That is the same as null in Python.
Sure.
Otherwise, I'm just gonna access this map that is mapping the link. And yeah, this is gonna give me access to from the current website link to the S3 bucket link that is stored inside our hash map of links. And yeah, our cache of images, right? That is this bucket we just assumed. And then yeah, just you need to delete actually. So so for the delete image is the same thing. Going to receive a link, right? And then if same thing, same verification, if link not in hash map, We just return none. Otherwise, we just going to do this del hash map on the specific link. So
there's what is this del? Is this actually
del means, yeah, del is a Python command to delete a specific hash map
Sure.
Okay. Element.
Just want to make sure.
Yeah. So let me see if there's nothing else. I was not talking.
Get image, delete image, and then you also have an insert image function.
Yeah, basically that's it.
Okay. Where's your insert image?
Oh yeah, the insert. The insert actually. So insert. Image. I'm gonna receive a link and basically map this to the hash map. One thing, I just need to verify actually if it's in the hash map. I don't need to put there. So yeah, it's just add actually.
Okay.
Actually, we're gonna receive a link, right?
Okay.
And like the S3 link, because like to insert an image, you just need to know like the original link,
Sure.
right? And the S3 link, that is where we are caching.
That's fine. Okay. So a few things. Remember what we said before about you have an arbitrary large number. You can only hold up
Yes.
to m, and then you also have an
Yes.
eviction policy that you need to implement. What do you think would be good here, and how would you enforce it?
For the eviction or for the like de facto?
Well, both really, because you have a m number, and once you start breaching that number, you are gonna need to get rid of some images. So
Yeah. Well, the first thing I was thinking of is to align this with the eviction policy,
Okay.
right? So, for example, when we start this image cache, we can define this m number, okay? So at every time we try to insert an image, and we overpass this number, this m number, we can use a eviction policy to get rid of some elements, right? And to get rid of those elements, what I was thinking that is the most obvious for me, at least, is to think about there are some policies we can use, but the most obvious for me is like last used it,
yeah.
right? So like the one that is have have less access is gonna be the ones that are gonna delete,
Okay.
right? To get to open space for new ones. But there's also like another, we can use like we can have a counter of number of times that some kind of image is accessed, right? For example, one image is accessed 10 times and the other is accessed 2 times, right?
Yeah, let's
So-
go with the LRU for now, the least recently used.
Good. So I'm gonna assume that.
Okay.
All right. So basically, the we need to keep track. Not. So basically, at every time we get an image, right? This number that's gonna mark like the timestamp that we used.
Okay.
Actually, let me just clarify a few things here. We can use for the last used, we can use I guess a timestamp. Let me think. Actually, that's not so clear for me. So for the last used item, I imagine that we have here Yeah, imagine that we have here like a tuple with the link 1. And the last time I used this was in the moment 1. Let's consider our timestamps
Mm-hmm.
as like access numbers, right? So I use this in the moment 1. And for the link 2, I use this in the moment 2. And then at some point I access the link 1 again.
Yeah.
This is gonna be the moment 3, right? The second 3, I guess, like the time of access 3.
Mm-hmm.
And imagining that my m is the size of 2, right?
Mm-hmm.
And I want to add a new link here, like a link 3. What I would choose is the one that had the minimum number. Like, I will get rid of link 2, right?
Mm-hmm.
And put the link 3 here and mark this as a link, as a timestamp 4. And yeah, that's pretty much it. But there are some things we need to consider here. Here is just an example for 2, but imagine that is a greater number.
Okay, I see. I see what you're doing. I think you can do this. It's much simpler than just using a timestamp because you don't care what time. You just care about the order in which the links um are are accessed.
Okay. Let me think about this. The order. You're saying like one link is access the order. I can have like just like a keep track of the last links I visited, some sort
Yeah,
of
you don't
thing.
need the timestamp. You only need to keep track of the order in which you visited, or whatever, or should I say, they were doing requests. So.
Order. I'm just trying to understand where this is gonna help.
Okay.
Order. Like the order I can think of the last, like the most recent is the ones that I can discard. Like I can delete. Cannot. But the more oldest, like which means a bigger order is the ones I can delete. So imagine that I have another structure that holds the order. Let me think about something here. And starting over, like link 1 is added on moment 1, and link let's put link 2 is added on moment 2. Like the order is starting with, okay, starting with link 1. That was the first one. Then I added the link 2, right? And imagine I want to add the link 3 here. Let me just think how the order is gonna help me.
Okay.
Yeah, trying to add the link 3. What I would, okay, so imagine that this is a list of orders. I know that on my left hand side is the ones that were kind of the last last used, least used it, I mean. And the right hand side is the more newer stuff. So I would take like my index 0 here, right?
Sure.
And delete this on my hash map.
Okay. You're deleting things from a hash map. Okay.
Yeah, this is gonna be all of 1, but here in the list, I was wondering if we delete this, it's gonna be all of n, right?
Okay.
There's this complexity I need to handle.
Okay.
Yeah, because opening space here on the hash map, I can now add the link 3. Okay. Doesn't need to add this flag of the timestamp here.
Sure. So
And then
this
I just gonna,
small thing. Okay, fine. Sure.
but yeah, and then the same thing. If I wanted to to add a link for, right? That is not in the list.
Uh-huh.
I would just take like my index 0, that is this one, right? And then, yeah,
Okay. So what's...
and put the
Okay, go ahead.
link for. Yeah, go ahead.
Okay, that's fine. That's fine.
But here's the thing, like, as I mentioned, if every time oh yeah, there's one thing that can help us here.
Yes, there is a...
Of
Go ahead.
Instead of using a list, right, that has a time complexity of all of n to delete the first element, we can use a deck that it's gonna give us like all of one time in deletions.
Okay, there you go.
And so, yeah, that's basically, it's gonna be a queue, right? So the deck's gonna be reference to the queue here.
There you go.
And yeah, that's pretty much it. So just rephrasing what I said with more accuracy. Every time we want to add a new link, right, that exceeds, and our hash map exceeds the m defined number, we're going to take out the first element of this queue, right? Delete on the hash map all of one time, and then that's pretty much it. And then we're gonna add on the end of the queue.
Okay.
Pretty much it, and append on the right hand side. Okay, so it's pretty clear. How can I do this? Is it okay if I implement?
Yeah, go ahead. You know how to do it, so you're good.
Yeah. So, like, for inserting an image, I need to do a verification. Actually, starting from the beginning. Whenever I instantiate this class, I need to have a m, right? That is the size. So I'm gonna receive this as an argument here, m.
Sure.
And then, is it okay if I define as a size, right?
I just
Yeah.
used m arbitrarily, but yeah.
Yeah. Okay, and then, yeah. Actually, I was wondering to have a counter, but is redundant because we can take the counter, like the length of the hash map.
Okay. Yeah, you already have,
and that-
you already have the hash map size, so.
Yeah, so, and this is going to be the priority, like the last. I'm gonna put this as a cube. Right? It's going to be deck in Python. There we go. And we'll start with the get method is gonna be the same thing, right? Because we don't make any changes on the structure.
Okay.
So the get method is still the same, but the insert method is the insert and the delete is where it's gonna change. Actually, there's a point here that I didn't consider. For the delete method, right? When we are deleting from the hash map, it's totally okay because we can maintain the all of one time. But when we are deleting from the deck, we will need to traverse this deck because imagine that, for example, I want to delete the element 4, okay? To traverse first to the element 3. And this is gonna give us like a all of n time complexity.
Yep.
It's not very good.
Let's say for now, it's okay to have an order n for that. At least for that case. It's
Okay.
Okay for now.
Okay. Okay, so I'll be inserting on the hash map here. As I mentioned, the first thing is I'll insert on the hash map, but actually now I need to check if the length of the hash map is equal to the size we previously defined. We need to take one element out of the queue. So, like, element delete, it's the Q. Up right.
Mhm.
We locate this on the hash map.
Mhm.
This element to delete,
Mhm.
and yeah, and then we do delete from the hash map. Clearly. Then we open a space on the hash map, and then we just insert our link here.
Sure.
Then that's pretty much it.
Okay.
And actually, we need to add in the queue, in the end of the queue.
Okay.
So yeah, self queue. And in Python, if you just use append, it's gonna append on the right-hand side.
All right, that's fine. Okay.
Yeah, and to delete is where we need to think of the other case.
Mhm.
If the link is not in the hash map, same thing, we just return none, right? Otherwise, we yeah, actually there's one case here. Yeah, I was wondering, like, for the insert before I move to the delete, like if the link is already on the hash map, I don't need to do those things here. I just
Yep.
yeah, there is nothing to do if the link is in the hash map. So just to handle this. Okay, if return. Okay.
Well, here's the thing. If it's already in the hash map, actually, okay, that's fine. That's fine. Yeah. Yeah. All right. Okay.
Yeah, because I don't need to execute this. And then for the delete is like the other stuff that I was saying. First thing is to delete if it's not in the hash map, it's still the same. Delete. I will delete from the hash map, but here is like the worst part where we're gonna increase the complexity. We need to delete from the queue as well.
Okay.
So
Go ahead.
go ahead.
No, it's fine.
Okay.
Fine.
For elements in the queue,
Uh-huh.
if element is equal to the link, yeah, I just need to actually just a minute. I'm going to delete the index of it. So I have this to delete, starting with 0, and then to delete is going to be the index. Then I need to do this here. That is to delete self here the element to delete. Right. So this last portion is going to be all of n because we need to traverse through the hash map. In the worst case, we go into the last element.
Okay. Fair. Now,
Okay.
Okay. Is that it?
Actually, I can test this.
Okay.
Is it okay?
I mean, you're free to test it, but I can already see a glare. There's definitely a glaring issue already.
Okay, let me just revise this.
Well, in general with the overall code, but yeah.
A general issue, you're saying, right?
There's a general issue. Yes. There's a case where you might run into some problems.
Okay, so let me think of. Actually, if I want to delete an image that is not in the hash map, I'm handling this case.
Okay, that's fine.
If I want to delete a link, I represent an image. Okay, otherwise it's on the hash map, right?
Okay.
So basically, I will delete from the hash map and starting this variable with 0, and then I'll try to traverse like my entire queue. Yeah, actually, yeah, there's a problem here. There's a bug here.
Okay.
Index is equal to the link.
Sure.
So when I hit the index that is equal to the link, I save the index, right? And then here, I just delete, like, from the queue. Okay.
I see. Okay, is there another issue?
One corner case that I can think of is, let me think. Because like all of the things that are inside of the hash map, they are reflected on the queue.
Mm-hmm.
So basically, those are the same.
Okay.
Mm,
What's one issue that you could run into?
let me try to see on the insert. Maybe it's on the insert. Okay, if I try to insert a link that is in the hash map, I will. There's nothing I can do. I just return. Okay, that is the case where we out of space on the hash map.
Mm-hmm.
Then I will pop. Actually, I will pop left,
Okay.
left, and then I'll take this element to delete, and then delete from the hash map,
Okay.
and then map the new S3 link. The link with the S3 link here.
That's not the problem. Okay, but sure, yeah. I'll give you another 2 minutes before I tell you what the problem is.
Okay. Actually, let me just generate few examples because just thinking handle this complexity is kind of okay. So that's the queue. All right. So imagine I just add the link 1, and then yeah, I just put in the queue here. And I'll put the link 2. Right, pretty much the same thing. Okay, and then I want to add the link 3. Imagine that our M is size 2. What I'm gonna do is delete the 1. Yeah, that's what I'm doing here. Then yeah, I delete from this, and then I traverse into the queue to delete there, and then I'm gonna add the link 3. Link 3 in the hash map. Okay. I can see. Okay, I want to delete all of the elements. Let me see how this goes. So yeah, I'll delete the link 3, deleting from here. Then I'll delete this from here. Okay. Oh, okay. Oh, there's another case. I was not thinking. Let me think. If, for example, I have an intermediate level of like I add first the link 1, link 2, and link 3. Okay, just replicating this to here. Okay, just to see if the queue is gonna handle the order of the visited. Okay, imagine that the last one I visit is the link 2 here. The last one I visit is the link 2. And this is on the middle here. And the order that I visited is the link 3. And Um, like I want to imagine that m now is equal to 3, and I want to add link 4 here. Well, basically I will delete the 3 and just put the 4. I think it's gonna handle like the case of the last used it, right?
Okay.
Hey, okay.
I'm gonna tell it to you for the sake of time. Basically, what happens
Uh,
if you keep repeatedly accessing the same link? What happens to your queue?
It's gonna grow.
Yes.
Yeah.
And so potentially, if over time people just keep accessing the same links, you got a problem.
Uh, access, not.
Because you have
No, actually, if I keep access, I'm gonna use the method get image, right?
yes.
So nothing's gonna happen with the queue,
Okay, I see what you did here. Okay, so then let's
right?
let's stop and consider something for a second. Least LRU. Do you know what that means?
Less recently used, I guess.
Yes. So what you did was least recently inserted.
Oh yeah. Mm, was this? Oh yeah, you're right. Yeah, on the get image, I'm not doing nothing. You're right.
Mm-hmm.
Oh yeah.
You completely
Mm,
misunderstood that. Yeah.
that's an issue. Yeah.
Mm-hmm.
Okay, so is it okay if I propose a fix?
Yeah. Go ahead. Go ahead. Fix it.
Mm, yeah, one thing I'm gonna do, like the most obvious thing I'm gonna do is like just remove from the queue,
Mm-hmm.
do a linear search on the queue, just the same thing I'm doing here,
Sure.
and then
Also,
add
also
on the right
for this
height.
one, don't no need to put it in the insert, by the way. So, but okay, keep going.
Yeah, just basically going to uh yeah, just traverse the queue, right? Delete it from there. Just
Sure.
the same thing I was doing on the
Sure.
delete,
That's fine.
right? And then append the current link on the right hand side of the queue.
Okay.
Basically, that's what I would do.
Okay. Sure.
So yeah, actually queue and link. And then now I know where like the one that is last used. Yeah, and now I'm considering the get and the insert. Does that make sense?
Yeah, that's fine. Okay, I'm gonna stop here for a little bit because we're at 47
All
minutes.
right.
All right. Tell me what you think you did right. Tell me what you think you did wrong.
Mm, I think in the beginning, I was talking about things that doesn't necessarily need to do with the problem, right? I guess.
Okay.
Mm, uh, one thing that I usually do while training,
Mm-hmm.
but I kept thinking about this when you said like design like a system, right?
Mm-hmm. It's not really a
Um,
system. It's really the code for it.
yeah, I haven't like scoped my idea. I know in like a plan, just like I do.
Mm-hmm.
I just assumed that I knew, and this gave me some problems because, like for example, this huge problem on the uh, get method, right?
Mm-hmm.
Uh, and if I have listed like what I needed to do for each one of my methods, will be much clearer of the steps. So this thing of sacrifice time over assurance, right?
Mm-hmm.
Uh, yeah, I think like if I could go back in time, would be a thing that I would do. It's just list like things I need to do, blah blah blah.
I
You know?
I think you already did that. So let me make it more clear as to what exactly you screwed up on. Basically, you spent too much time on things you had already figured out, and you didn't spend enough time on things you didn't. So let me explain what I mean by this. So you actually did a pretty good job at handling a lot of the things at the beginning, right? This
Oh.
so overall, I'd say the first 6 minutes are pretty good. Well, first 10 minutes really scoping out everything. The first sign was like the eviction policy. It seems like you kind of left this dangling. But like defining the functions that you need and kind of reasoning it out, that's fine. I felt like it was a little bit slow, but for the first 10 minutes, I think it's an obvious opener. The second thing I noticed was that it basically took you 3 minutes to describe that you need to use a hash map underneath it, which should have been instantly obvious. Because do you really need to say it's obvious to look through an array and a linked list before you get to the hash map solution?
I was trying to go over, not consider the hash map as a magic bullet, you know.
Yeah, but the thing is that there's a
Just
difference between that and a magic bullet and something that's just so plainly obvious. To me, this is plainly obvious. Magic bullet means, oh, I'm gonna YOLO this random thing and fix it, right? Because we should be able to go through this step by step, but you should be able to do it very quickly in your head. So this needed to come out faster, for sure. That was like one of the big red flags. Like, wait a minute, and it's like I know where you're going with it. Just get there.
just get there. Okay, skip like all the bullshit.
You already
Okay.
know. You already know. I think you already know that this is bullshit.
I already knew. I already knew. Yeah, I was just trying to explain that I like the other solutions, you know, just
Yeah,
trying to invent.
but
Yeah.
this is something so simple that it should have been obvious. It's like, do I need someone to describe to me how to walk? Like, here's how you
No.
walk to the store. You put one foot in front of the other and make sure you push back with the foot behind you. I know how to walk. I'm a fucking grown ass man. And it's like, it's the same thing here. Like, you already know the derivation for the hash map, so it's obvious. So,
Yeah.
okay, same thing. You were kind of basically talking about recommenting your code and stuff, but it's just like you already described it up here. Get image, get insert, and delete. You already had that. So I don't know where this commenting and trying to with the commenting was when you started writing the actual code. It's like you already knew what to do. I don't know where it came from again. So
Like what in specific?
yeah. So if you rewind it, you'll see like, hey, if there is a image in the hash map, I will retrieve it. If there's no image
Oh
in the
yeah.
hash map, I will go and get the S3.
Oh, I was trying to be clear again, but yeah, that was too much.
Right.
Yeah.
Again, it's something so it's like it's not that complicated of an idea, right? Essentially, what we're
Uh,
describing is just retrieval from a hash map. Again, it's
yeah.
so plainly obvious; it doesn't need to be explained.
Okay. Yeah.
It's like knowing where it's like, oh my god, you're losing the interviewer. If it's like I said, remember how I said like it's basically chewing dried chicken? That's what this feels like. It's like it's so obvious. Why are you explaining it to me? And I think when you yourself say, why am I explaining to this guy other for the sake of completeness because it's so obvious to me?
I acknowledge the problem.
Yeah. It's like if it's not that if it's like something where you feel like someone else might get confused, this is fine. But do you really
Uh,
need to explain how that you're doing a hash map retrieval? Like you don't need to go to that level of detail. Just say, "Hey, I'm going to retrieve an element from a hash map, and if it's null, if it doesn't exist, I return null." Plain and
uh,
simple. That's basically what you burn the most time on, just like this trivial nonsense that you already know about. So okay, so describing the eviction policy, I would say the next thing is that this derivation for the DQ is that it basically took you like 7 to 10 minutes. To me, that's way too long. So for instance, like I get it, you want to describe the LRU in timestamp, but I'm basically telling you here that the timestamp doesn't matter because all you care about is the order in which you access things. And so and then you realize it's DQ. This should have come out faster, I think. And I'm not quite sure how to explain it other than you need to know your Python data structures much faster and better.
but I showed you like exactly what I need,
Yeah.
like when I need, you know.
Right, you showed it to me. You went through this step by step. That's fine, but it's the same symptom.
Uh,
It's like you could have just went through this and realized, oh wait, this timestamp solution might be taking too much space. And even then, like I already told you that hey, you don't need to do this. Like let's say I'm forgiven and said, okay, yeah, like you got lost and sidetracked by the timestamp solution. It takes you 5 minutes to realize you can use a DQ.
And you also need to give me a hint, right?
Yeah, exactly. So it's like you should have been able to do this much faster, and this is that comes down to knowing your Python data structures and being able to work through something so plainly obvious very quickly. So it's kind of going back to that. It's like what is obvious, what is not, and being able to kind of skip those things, the meaningless discussions, right?
Yeah,
Um,
yeah.
and so the mistarted LRU, and then everything else, it's like okay, a few bugs, right? Remember what this with this one, the self queue link index. Yeah, this one is gonna be uh, an issue because now that you're basically iterating through a queue and then you're storing the to delete index, you could also break out of it and then like delete from the queue as well. But this also assumes that the queue only has one element, like one instance of the index in it. And then there's
Yeah. If I
also
try to break here, if I try to, yeah, one instance, you're right.
right. So there's a lot of
No,
implicit
yeah, but
assumptions.
I'm guaranteeing that it's a hash map, right? So, like,
But you're iterating through a queue.
there's, yeah, uh, and I'm assuming that every time that I want to delete, I'm gonna delete like the element, right? So there's not gonna be repeated elements on the queue.
Okay, that's also the thing is that well, do you think what you proposed up here is the cleanest way to um like actually manage the queue?
Mm, yeah.
Because like when
Oh,
you do your get image, you're iterating through the entire queue every single time.
actually, I could just have break like whenever I found what I
That's
want,
that's
you know.
fine, but it's still order n. This is just a small optimization to
Yeah.
jump the runtime.
Yeah, that would be a thing that I will try to improve,
Right.
as I already said to you. Like, but that was the most obvious thing.
It should have been each step should have been plainly obvious about what can go right, what can go wrong. Up until this
No,
point.
that I acknowledge this point for you.
Right, but it's
Like,
like you need to be much faster at it. It's like you acknowledge it eventually, but it's like, well, you need to lead the discussion a little bit more and be able to say, hey, this is what can go right, this is what can go wrong, and be able to drive it. I shouldn't have to like, uh, basically the overall spirit I'm trying to say is that a lot of discussions that we had was basically you kind of stalling out. So it was like 5 minutes here, 5 minutes there. We had like basically 3 or 4 instances of that. That's 20 minutes of the interview right there.
you're right.
So that could this entire progress that took you 45 minutes, you could have done this in like 30 minutes or 25 if you're fast. But it's about knowing what you can and can't skip, and once you get that down, then it's gonna be much better. But basically, it just took way too long. So if this is like, I know Google likes giving problems like this, but a Google interviewer would probably have failed you for being too slow. So and I'm not taking any chance. Like Microsoft could easily be as stingy.
What is cinema of stingy?
Let's just say anal about it. Very strict, too strict.
Okay.
Yeah. So I think we might kind of talked about this before. It's like you should be able to do this, like these blocks in your head, and then immediately go to them. So
Okay.
yeah. So your
I
process
will.
is fine. It's bulletproof, but it's just about being faster at it. And we've already had this
Faster.
discussion of how to get faster at it.
Yeah. No. Yeah. For serialize, I guess serialize and deserialize.
Yeah.
Like I did like I rewatched the video I guess 2 times
Uh huh.
after our stream, and trying to identify the points I could have been faster.
Yeah.
But like, is the pattern where I told you, like, when I put pressure, um, in terms of time, like much more bugs start to happen, and like my accuracy to do the right code, start to decrease. It's like a um inverse proportional,
Yeah, that's what I'm saying. Don't look at
but
the time. Don't like because in a room, if you let's say like you end up in a room or whatever, right? The interviewer is responsible for managing the time. You're responsible for
yeah.
showing that hey, your process for evaluating these problems is super high quality. That's what you're trying to expose. You're like the time is just like okay, well, it's just a constraint, but it is not
Mhm.
a determinant. It's let me see. That's a little confusing. Let me try to describe it. So, let's say, for instance, you're playing basketball, right? Yeah, it was like 42 minutes on the game,
Yeah.
and you have 42 minutes overall at the beginning. You like 42 minutes to make as many baskets as you can using the cleanest plays that you can. That's what you want, right? But then
Mhm.
now, let's say I put 10 seconds on the shot clock, right? So,
Mhm.
in given X situation, how do you make a basket in 10 seconds? Like, okay, well, I know I can, like, if I do this play, it's going to take way too long. But if I do
Uh-huh.
this, it's going to get me, it's going to have the highest probability of success. But the thing is that everything you do before that is a setup to that. And that's going to be much more determinant of how much time you have left than that one moment. That one moment is just like make or break, but you can usually avoid that. It's like when you play a game of basketball and it's like 96 to 12, you don't care about
Mhm.
10 seconds on the shot clock. You're already at 96.9.
Yeah.
So if you do the setup correctly, you will have plenty of time. But if you screw up on the approach, you'll end up in that 96 situation where it's like, okay, I have 10 seconds on the shot clock and I need to make or break the game on this, which is a very delicate situation. Our goal here is to avoid that to begin with a clean approach and being able to save ourselves time on all the stupid freebies.
Mhm.
Does that make sense?
Totally.
Yeah. So if you had just been a little bit faster at figuring this shit out, like, oh, well, I don't need to talk about the derivation for a hash map. I don't need to talk about the derivation for a DQ, and so on and so forth, you'll find that you'll recover a lot more time than you think.
Yeah, and put more time in what really needs, right?
Right, the more nebulous situation, because imagine, like, in that situation, 96, a situation, and instead of 10 seconds on the shot clock, I give 1 minute. Not that hard anymore, right?
Mhm.
You can take your time
Yeah,
and,
for sure.
yeah,
Like comparing to the previous, yeah.
exactly. I can we can have 2 or 3 shots at trying to make that basket, provided we don't fuck up and turn over the ball.
Mhm.
But the point still
Yeah.
stands. It's like the approach is almost always going to be determined 80-90% of all the shit of everything that gets you to that one moment. Don't focus on that one moment. The one moment is just like, okay, it's make or break time, and you do what you think you need to do. But everything before then you have much more control over. So
I see. Well, one concern that sometimes I have is like sometimes if I get too quiet,
yeah,
like you're, I'm not gonna be so clear in what I'm doing, you know. So okay, so basically, for example, just an example, we're gonna have to iterate through the queue and then delete from the hash map.
okay,
And then if I spend like 40 seconds, no, yeah, let's say 30 seconds just coding this or 20 seconds without saying nothing,
that's fine.
maybe that's fine. All right,
I see you're
nice to
working
hear.
on it, right? I was like, if you're type, like, that's cool. I get you're working, but it's like, it's 30 seconds when you're like, when it's like 1 minute, 2 minutes thinking and dead silence. Like, oh, that's where it's gonna
Yeah,
suck.
yeah.
But if it's like dead silent
Okay,
when you're typing shit up, I'm fine. I know what you're doing.
I'd say I'm much more faster if I do this, you know. So for example, okay, yeah, I'll say what I'm gonna do and then type like
There you go.
uh 30 minutes typing and like 10 minutes talking, you know. So 40 seconds, and but if I do two in the same time, it can go like to a minute and
Yeah.
30. So that's another point I've been
You already
like
described your get
perceiving.
image algorithm. It's like, okay, I'm gonna if this link exists, if it doesn't exist in the map, I'm gonna return none. Other than return, and then like spend 10 seconds, like 10 or however long seconds typing that. Right? It's like, okay, you already said what you're gonna do. You're executing on it. You can divide that. That's fine. You don't have to keep talking while you're typing. But
I'll try a
again,
few questions using this approach.
huh?
I will try a few questions doing this
Yeah.
approach just to see how that goes.
Right. And always make sure that you pay attention to when things are just like, oh my god, why am I talking about this? Like this instinct should have immediately come up, like, because that's where it's gonna save you the most time. That's where I really want you to focus on, because once you again, like I said, you recover that time, you will have time to think about all these little issues, like, oh my, like, excuse me, like what happens
Uh,
if what are things that can go wrong? Oh, what happens if I keep accessing the same element, and what happens to my Q
yeah,
sets? It's also part you need to also recognize that. I think I had to recognize that for you. So,
yeah,
so,
you're right.
but yeah, if you had a little bit more
Okay.
time, you probably could have spent more time figuring this one out. So that one is more of a how can people use and abuse what I've written. So for me, it's just like, okay, well, is there, because like when I look at it, I say, okay, there's a size limit that we have, right? So hash map generally not going to have the size problem because everything unless we like add more images, in which case it's very obvious that we just evict a random image from a hash map, and that's just order one time, just set it to none, right? But the problem now becomes a lot harder when you add another data structure. It's like, okay, well, if I have to parse down the queue size to size M, I can just evict random things, right? I can just evict things from the back and just call it a day. But what happens then? I'm starting to think to myself, what is wrong with that? It's like, okay, what? It's like a little bit of it's like, hey, did you think of something that can go wrong? Like, okay, well, the thing that can go wrong is that, well, what happens if the queue is just full of the exact same image? Like someone accesses the image cache 100 times for the exact same image. Then it's just like, oh well, shit, that just blew up the entire, the entire queue.
Yeah. Yeah.
It's about like, okay, sense. Now that I have this implementation and this idea in my head, what are the things that can go wrong with it? How do I make it more robust? So.
That makes sense.
Okay. Yeah.
I'm following your line of thought.
Yeah. So it is like right now we're getting to the part. Remember how I said before we had to get to the approach and then making it faster. Now we're trying to train the instinct. This is another part of the instinct that needs to apply the instinct to your approach, because like when we began, the approach was always like trying to be methodic, trying to be bulletproof. Now we're trying to train the instinct to override some of that. So it's kind of undoing a little bit of it, but it's always situational and by your judgment.
Okay.
So it's a little bit going in reverse, but we're trying not to be careless about it. That's the key. We want to get rid of the obvious mistakes, but the super not obvious ones, like some of the weird optimization, like some of the weird conversations that you had, where you were like trying to be really careful about the S3 retrieval, I would say leave that alone, because for part of it, part of it was like you didn't acknowledge what I said about the S3 image retrieval. But I think the conversation at the first 10 minutes was actually completely relevant. I don't think you should have made any modifications on it, because you were trying to scope out the problem. It's these obvious ones that you should be fixing.
The obvious, like the hash map, like the queue. I know that.
Yeah, exactly.
It's pretty obvious. I'm like thinking to myself now.
Yeah.
And you are like a 10-year engineering experience, right?
I mean that's really what I would say. I figured this one out when I was like 4 years in, actually. It's like I don't need to talk to someone about. It's just like a conversational thing, right? If the person obviously knows like what they're like has that background, you don't need to explain things to them. You don't need to explain the really basic stuff. You can just move on to the advanced stuff and the things that actually matter. It's about contextualizing the conversation in general.
Yeah. For example, just one question here. If I say to you like, so here I'm gonna do a for that is gonna traverse through all the elements. It's pretty implicit, right?
Yeah, you can just even say I'm gonna traverse all the elements in a queue, or I'm gonna traverse, and that's it.
That's it. Yeah.
I don't need you to tell me like what a for loop is.
No, you already knew on your first year of undergrad. Yeah.
Exactly. So like it's about getting to a higher level of conversation and then being able to bring it down a level or two whenever you need to. And where people get it wrong is when they really jump to it, but then have no idea how to bring down the level of conversation to the details when they need to. So we've been trying to build up. Now we're trying to just get to the right level of conversation, so that way you don't have to go through the boring ass details, like the linked list array thing. So, all right, I know it's kind of late for you. So let's call.
No, it's all good.
All right.
So tomorrow is weekend here.
Yeah, tomorrow's weekend. I want you to get enough sleep so that way you can really hammer on this instinct thing. So
yeah.
Are there any other questions you got?
For the graph problems,
yes.
I just want to hear your point of view. There is like one specific type of problems. I'm still having, I'd say, it's not so trivial for me because I left a lot of bugs.
Okay.
And I'm not satisfied.
Yes.
Like those questions where I give you, like, for example, a weight, vertex in an edge,
Yeah.
Like a set of those things, and you need to perform some sort of algorithm there.
Yes.
So, like for example, I had like one of this problem, Amazon online assessment of last year, right? And I just And actually, I did uh, those type of questions just like Thursday, and I still like kind of. I can go. It's much more easier for me now to think about the general algorithm, to solve. But sometimes, like, they're too specific. For example, one is like Prim's algorithm, the other was Dijkstra, and I had to like review this. Any thoughts about this? Should I?
I think just knowing how to do it in general, but then being able to
Mhm.
do it on the spot. It's like you know it's like Dijkstra's algorithm. I completely fucking forgot. I think it's like what sort the weighted vertices by sort the edges. Yeah, sort the edges by weight and then iterate through the edges and then try to build the path based on that. I honestly, I will
Actually,
tell you straight up, I will
yeah.
fucking fail a Dijkstra's algorithm problem, but I can also tell you that most engineers are not going to focus on that once you get into your career. Maybe as a new grad, because you just freaking studied it, right?
Yeah.
But for the most part, I don't think most people will try say, "Aha, you don't know Dijkstra's algorithm, you fail." It's just like you should know it, and you should be much more
Uh,
familiar with it than I am, and you should be able to come up with it off the top of your head. It's one of those patterns that you should be able to
yeah.
write from memory.
Oh yeah, yeah. I was rewatching a few classes just to know the general idea. Because for example, for tries,
Yeah.
I know the general idea, and when I try to implement was just perfect.
Uh huh.
So if I have this general idea and like the details, I can do this pretty with excellence. Like it's pretty okay for me.
Yes.
But I was wondering if it's okay if I do a review of like, for example, some more specific sorting algorithms may I don't know, maybe it's valid or not. Just to hear from you.
I would say for now, it's more. I think we get more impact out of trying to get this. I understand where your concern is with graph, but for the
Uh,
most part, I think that is something that can come in less than a day. I'd rather you work with this. Does that make sense?
work on the instinct and get rid of this
Yeah, because
small
that's a more
talk.
obvious mistake that will help you throughout multiple problems, whereas what you're describing
For sure.
is just one problem.
For sure.
So,
For sure. For sure. Yeah, you're right. You're right.
okay, yeah. I hope I'm
Okay.
right. You know.
No, yeah. No, I think your instinct is better than mine, so
All right.
probably you're right.
All right. So I'll let you go then.
Okay, man.
All right.
Okay, bye, man.
All right. Later.
See you.
See you. Okay. Mm, all right. So we have 1 week till Microsoft. So let's hope that worked. Anyone have any questions in the crowd? LRU cache, image gets deleted. Sound like LRU cache? Yeah, it is basically LRU cache. I just disguised it as a image library because actually, there's a lot of nuance to it. The reason why is because if the conversation progresses enough, you can actually start talking about caching multiple instances of the image. So, for instance, let's say you have some, 10 megabyte image, right? That you're trying to access. Now, the thing is that you might want to cache a thumbnail version of it that's like 2 kilobytes before you load the 10 megabyte one. And that's where like having multiple what's called keys and images can actually come in. And this is like where if you're really good and you really know what you're doing, you can evolve the conversation like that. So that's why I specifically say image cache because it's like LRU cache but with room to grow the conversation if the candidate knows what they're doing. He should ask. He should ask how the user is using the library. Yeah, that's true, but you should also be thinking about how the user might use the library as well. Because I mean it's a little bit hard considering that this is basically a new grad, and this questions like these are more generally just designed for people with industry experience. But I still think that he could have done a much better than this, because it just boils down to a simple LRU cache. That's like the minimum bar I would expect for a L3 engineer to do it. Like implement an LRU cache basically. So, yeah, it asks the user will be getting images. Will they use a lookup, maybe an ID key? Yeah. Again, that's up to how far the user and the person get. Anyway, I will go ahead and bring up Hacker News for like a minute or two. And if I don't get any new questions, we'll stop the stream. Yeah. But I'm just like, I'll browse and wait for like you guys to ask me some stuff. Twitter CEO fires 2 top executives. Holy shit. He wants to take the team in a different direction. Kayvon. I'm doing Amazon and Microsoft's open assessment in 2 weeks. It seems like the market is freezing. What do you think the best way to get interviews with more companies is as self-taught with 1.5 years of experience? Basically, if you are really good, companies will shell the money out to hire you. There's a hiring freeze. Yes, that means that we're not as liberal with hiring, but if you're the fucking best or you're exceptionally good, we will hire you. It's like, for instance, Jake Wharton. I love bringing this example up. Let's say, for instance, that he fucking decides, hey, I'm gonna quit Square and join Uber. You know how quickly we would say yes. Do you know how look at all the shit that he has made, all the repositories that he makes that have high contributions that he started that are basically widely used in the Android sphere. Do you know how quickly we would fire all our engineers just to hire this guy? I'm telling you, if you're good and you're worth the money, people will hire you. And so the question now is, how do you get that good? And how do you demonstrate that in your interviews? So, for system design, do you recommend Grok in the system interview or any other resource? Grok in the system interview and designing data-intensive applications. Between the two, I've already described how to basically use those two resources in the guide and description. But basically, the idea is you do a system interview and you compare it to what Grokking has, right? And if there's any discrepancy or any part that you feel weak on, you read the corresponding chapter in DDIA, and then you try to apply it for the next one. Or at least even try to apply it for the current one, for the last problem that you just did. And you just gotta rinse and repeat that over and over again. You realize you're really weak at sharding. You read up on sharding and leader election in DDIA. You realize you're weak at caching. You read up on caching in DDIA and try to apply that. Under what circumstances do you use which policy, and can you reason through it? And that's basically how you use those two resources. I know like everyone's coming out with like, oh, the system design guide, but to me, it's always been like, it's always a bunch of bunk for a lot of these things. Let me actually show you something interesting. Actually, hold on, let me bring it up. It's like once you get the fundamentals, everything else is like shit. That's the way I describe it. So let me actually bring up my account here for Google Books. Ah, this one software estimate. I think it's this. Is it this one? I think it's this one. Okay, yeah, software estimations here. I think I think I was reading it at some point. Hold up. I swear to God, I had a I thought I read more of it. I could have sworn. Give me a second. There was like, yeah. Oh, okay. Hold up. Yeah, I think it might have been one of these pages. Like, there was like a formula. I know like they had some formulas or some shit. Yeah, something like this. Okay. So the reason why I want to bring this up. So one of the things is that when I learned how to try to improve my software estimation shit and my experience with that, I basically started reading books like this. But to me, it's just like it's like this entire fucking book. I think it's almost borderline worthless because like it's at the end of the day, it's just like, oh, there's just so much uncertainty and I don't knows. And this is just one example of like, oh yeah, this is like target completion date and actual completion date. And it's saying, oh yeah, there's like one experience, and then it's just above all this data points, and it's just like, okay, great. All it's saying is that the target and actual is just saying that the actual is just much more than the target. No shit, Sherlock. Anyone who has done a project can tell you that, you know. So it's just, and it's like, oh, there's more certainty when the project completion date is Smaller? Yeah, no shit. So what kind of data is this trying to tell me? Like, you know, and this entire book when I was reading it, I was just like what? It's like okay, I get it. Initial concept, software complete. Like there's a high amount of variability in estimates. Yeah, thank you for telling me that. I didn't need a fucking book and paid like $20 to know this. You know. So there's a lot of shit out there that just basically like, why are you writing this? It's not helping me. It's not. It's like it's just an increased amount of useless information that I can't use. So it's like that's why I say go back to the fundamentals. And in this case, if you just go with the fundamental idea that estimations are recursive, in like for instance, like it takes X amount of effort to get 98% of the way there, and then it takes that same X number of effort to get to 99% of the way there. You basically have this entire book in a nutshell. And that you realize that a project is never done. It's only ever recursively gotten closer to the end point. That's it. You just run with that idea. You basically have solved project estimation in everywhere. That's basically how you treat project estimation. And then you run through it like maybe once, and then try to figure out prior data points, and then use that as like some cluster of, oh yeah, if this cluster exists here for this estimation, then the worst case scenario that we can run into is going to be even further out. You run with those two ideas, you have project estimation done. So that's my little rant for the day, I guess. But the problem, so what I'm saying is that system design books, you don't really need to go beyond those two. I mean, you can and probably get some ideas from other books, but it's just like you're gonna wade through a lot of useless information and shit just to get there. And I mean, I try reading like the system design books as much as possible. So, like I would say like 90% of them are like freaking worthless because it's just too much information and not enough actionable information. So I just like that's why I like keep it simple. Just stick with like grokking and then go into DDIA. You know, again, I'm not sponsored by any of this shit. So, and these books and resources have been around forever. And all I'm saying is just, hey, use this resource, and if you fuck up with something, use the DDIA to look things up, and then go back to this resource. It's very simple. There's no reason to change it unless there's like, you know, someone who has come out with some very actionable guide that can consistently deliver results and improving on your approach. Which, to my knowledge, there isn't one. You know, there's books out there on like mobile system design and information, and that's great and all, but it's like it's not actionable. It's like it's just telling you, oh yeah, this is what a server looks like. This is what sharding is. It's like, congratulations, I know that from DDIA. Now, how the fuck do I use that information to improve my system design and analysis and my approach to it? And everyone's just like, I don't know. And so to me, that's like, okay, it's not better than what I'm currently doing, so it's fucking worthless. So. What about Twitter stock and Elon Musk? Based on my understanding of the acquisition, Twitter basically lied about a lot of their analytics, and Elon Musk might use that to try and walk his offer back, maybe the price. But to my understanding, Elon has a non-contingent offer attached to the terms. So even if Twitter straight up, like, I don't know what degree of misrepresentation Twitter can get away with, that would qualify. To me, my understanding is just like it's like putting a non-contingent offer on a house. And so it's like, okay, you're buying the house as is. Now, can you back out? Probably, because I mean, there's some earnest money in escrow, but you probably lose the escrow money. I'm not too sure how these deals are structured and done, but I will say that I don't know if it's gonna go through or not. What I am saying is that for Twitter to kind of hide the user data and say, oh yeah, we miscounted like the number of bots and shit, I think you should take a second look at the platform. I think a lot of interesting information will come out of Discovery as Elon progresses further with this acquisition, if he decides to go through with it. I can't tell you what the man will do, and I can't tell you what will happen with the offer. I don't think anyone can tell you, but I think you should pay attention to the information coming out about Twitter because of this offer. Can Elon just release that private information? I mean, yeah, probably. But I mean, given the amount of news coverage this deal has, I would not be surprised if someone is going to leak or put out information there that Elon doesn't even know about. So, like for instance, if we go back to like this story of some of Twitter uh, pushing out like top executives, I would not be surprised if one of these guys decides to leak something. If it's like if it's, this guy's like fucking pissed off or something, um, then maybe he might leak something to media. You know, it tends to happen quite a bit, more than most people really know. I mean, keep in mind, like this is all publicity, right? Everyone needs to keep a public face, but in private, people might feel away. But again, it's if you're trying to predict the future, I would say give up on it. You can't. There's a good saying that Howard Marks has. Is like you can't predict the future. You can only prepare for it. And I think it's just like you can't predict what is going to happen here, but you can at least read the information and kind of see where Twitter is heading and prepare for that. See, in a memo wrote at the beginning of the pandemic 2020, decision was made to invest aggressively to deliver big growth in audience and revenue as the company did not hit intermediate milestones that enable confidence in these goals. Yeah, and to my knowledge, I don't think Twitter is profitable, or if it is, it's got like very, very small margins. I think I remember reading that one in the 10K. We were pausing back on hiring and backfill. I think most companies are, except for business critical roles. Yep. Like I said, if you're good enough, they will hire you. We are pulling back on non-labor costs to ensure we are being responsible and efficient. Yep. Exit of design and engineering leads. Holy shit, that's a strange place to start cutting engineering leads. Maybe if it's just like engineering leads of products and projects that don't do shit. It's kind of that's a weird place to start cutting. The live stream company acquired Periscope. Yeah, live streaming. Sure, sure. Periscope was shut down last year. Yeah, this is where all the goodwill money is in like acquisitions of in like Vine and Periscope. So then we upgraded our ad serving and prediction and blah blah blah, blah blah blah. All right, whatever. Any other questions from the crowd? Hiding and fixing regressions in list data infrastructure. Okay, okay, this is good. This is interesting. This is interesting. I might actually read. Hold up. No, actually, let me take out my hoodie. Fuck, give me a sec. All right, there we go. Trino, open source infrastructure upgrading at Lyft. All right, I'm kind of curious about this one actually. I feel like this is probably something that I think people should read. Data-driven company, business critical decisions based on data. Yeah, no shit. To support the various use of data scientists and engineers, we use Trino as a company-wide service to empower interactive query scenarios. Okay. Okay. Okay, so you are basically using this as a data mining? I have no idea what Trino. Let me. There's a distributed Okay, a query engine that runs at ludicrously. Okay, it's a query engine. All right, cool. So it's saying how does this work? Interesting. Presto clients, Mozart Gateway, Presto. Okay. So where's Trino come into this architecture? Okay, this Trino architecture in general. Okay, I see. You have clients. They go to a gateway. You have Presto. I don't even know what Presto is. Beyond that, Lyft encourages teams to leverage other major data features of Trino, such as dashboard reporting and extractive volume ETL jobs. Our user service sends more than 250 queries with 50 petabytes of data processed daily. Growing user of Trino. The data is deciding to provide the latest Trino features and infrastructure upgrades to our internal customers, so we can unfortunately. Okay. Growing user Trino. Okay. I'm gonna read this and then I'm gonna come back to this diagram. I think this is kind of interesting. So you have clients that are going through a gateway and a proxy ad hoc structure, S3 workers coordinator. So it's just started jobs and scheduled jobs too. Okay, let's see. A load balancer proxy gateway for the Presto compute engine. Yeah. So it has no different than a web server actually in that case. The Trino community normally publishes 1 or 2 releases per month. We currently only upgrade every 6 months due to company-wide upgrades in infrastructure. upgraded our clusters from version 359 to 365. Failing to stay current with the most recent releases of a project may eventually turn into technical debt. Yes. Outline approaches and tips to help enable other data infrastructure teams to similarly scale and upgrade quickly while identifying safety identifying regressions. Okay. We upgrade Trino have been made. Team chose a build to use. We have not used the latest Trino as there may be regressions that have not been found by the community. So, okay, this is pretty common in version upgrading. You review and look at the most critical features. Team then pulls the branch of the selected release into a list-specific fork and cherry picks our patches so that builds within our infrastructure. Okay, fair enough. These patches include required bug fixes. Yes, to guarantee a new branch compiles and works as expected. Minor changes may need to be either disabled and are not compatible with our settings or just features that override settings. Yeah. Okay, so this is pretty common when you're maintaining your own fork. You want to add fixes that have not been merged in that you yourself are going to need very specifically. This is pretty common, actually. For a lot of experimental things. So for instance, like Bazel itself, if you want to use Bazel, there's a lot of forks and a lot of bug fixes that are kind of in limbo that you may want to cherry pick and add to your own branch. 3 main use cases for Trino: ad hoc, ETL, and scheduling. Okay, ad hoc clusters have taken care of interactive queries from users such as engineers and analysts. Designed to handle a large number of queries with lower wall time and higher global concurrency. Sweet, sweet. ETL clusters are designed to take care of longer asynchronous queries, which may have a longer wall time and higher utilization. Okay, a scheduled cluster, especially at ETL, is dedicated to dashboards and reporting with more predictable requests and volume. Okay. Okay, so you have 3 parts. One part handles the query, lower query time and higher concurrency. ETL is designed to take care of large asynchronous queries. So this is where you go if you have a giga-ass big query, and the scheduled cluster is a special ETL for dashboards. Okay, so large amount of small queries, small amount of large queries, dashboards. Cool. Moving forward with the URL use case testing, we launch the new version in staging clusters. Each representing a different use case to verify it can build and execute. If the testing cluster does not start up, we make necessary changes to fix and file issues with an open source community. Okay, so you have a bunch of different clusters in staging, and then you progressively upgrade each cluster. Fair. All right, wait, hold up, guys. Let me use the bathroom. I'll be right back. Okay, cool. All right, performance testing. After the staging is complete, we release the version to a cluster that is dedicated to performance testing. Okay, yes, fine. In the first round of performance testing, we replay 1 or 2 days worth of read-only compute-intensive production queries in batches called batch mode. Okay, fair. We replay 1 or 2 days worth of read-only compute-intensive production queries in batches. Okay. Compare the P79. Okay. So replay 1 or 2 days worth of read-only compute-intensive production. Okay, so you basically throw a lot of read-intensive queries at the upgrade, and then you say it's okay. And in batches, okay. Test high load scenarios. So you're basically hammering it to try and test edge cases. Cool. Why replay these queries on previous, even though we have already production to compare? First, we don't have to build a system to replay batches with identical timestamps. Okay, not being able to replay identical timestamp batches means that timing and load on the cluster is not comparable over time since the source data may change. Okay. Let me reread that. First, we haven't built a system to replay batches with identical timestamp. Okay. Oh, I see. So because it's a read only, it's basically saying, hey, let us on this system go back in time and replay this as if we had just run this on like this new version. So it's like it's basically a time machine essentially for the query. Not being able to replay identical timestamps means that timing and load of cluster is not comparable over time. Yeah, because let's say you run the query at, let's say you could take all these queries that ran in the past day when some other shit was happening, right? Let's say like there's a fire, right? You're querying, you're basically querying while a bunch of other queries are going on. But then let's say you bring it forward to today, well, and that fire's put out. Well, now the load that you're testing under is going to be different. That's fair. Okay, it's better to compare identical source data at a certain timestamp. Yes, correct. Another reason is that identical queries can potentially scan more data if they're run at a later date due to the partition being scanned and how the queries are. Fuck. Ah, God, I really hate it when people write like in long ass sentences. I feel like, I don't know, I feel like COVID did something to my brain where I can't read more than like 10 words. Like, I legitimately think I lost IQ. Like, maybe, I think my IQ like went down 30%. I cannot read more than a single line. Oh god damn. Okay, let's see if I can. Okay, another reason is that identical queries can potentially scan more data if they are run at a later date. Okay, due to the partitions being scanned and how the queries are written. What? Identical queries can potentially scan more. Can scan more data if they're run on a later date, because the partitions are being scanned and how the queries are written. So does that mean that if the way the queries are written, does that mean that on day one, the underlying implementation is like different from day two? Like if I like at like my SQL query on day one, and the performance changes on day two, well, and for the exact same query, then the thing underneath must be the one that changes. So does that mean that the thing underneath? Does that mean that the clusters and shit handling it underneath have changed? Why would it change without you changing it? Okay, partitions being scanned. Okay, yeah. I guess the partition being scanned, and I guess it's just indexing here. What about late arriving data? Not sure what you mean by that. You mean like data that would arrive after the initial query? Okay, if the P numbers are comparable on both versions in the performance testing cluster, we approve it. Okay, they're basically just talking about if the data is just like newly indexed. Okay, fine. But then that's arguments for why it's not complete testing. Actually, all this has been just talking about why replaying things it without identical timestamps is not complete. Like they even say here, they cannot replay it. We haven't don't have a system to replay batches with identical timestamps. Okay, so then they literally just admit that this would be incomplete testing. Okay, yeah. So that's why they're replaying these on previous versions. Okay, I see. So what they're saying is, okay. So they replay the queries. They don't take the actual data of the queries themselves. They take the query, then they replay it on a previous version at the same time as the new version. So let's say I have my SQL query like blah blah blah, select star from blah blah blah, right? Then I'm going to take that query in the past. I'm going to take that and apply it at time 0 on version, let's say 1 versus at time 0 on version 2. That's what they're saying. Goddamn. I can't believe it took me like 2-3 minutes to figure that one out. God, I feel stupid. There are no semantic differences between the versions. However, the wall increased significantly. Okay. We conclude there's a regression in 65. Okay, so there is... So the P50, P75, and the P95... So the P50 time actually grows The P75 times is pretty similar, and the P99 is actually smaller. So the P50, so the P50 range here is actually longer. What the fuck? So actually, you have like what did you call this, like fat tails? I think. No, the thin tails, right? Oh no. Yeah. I see. So you have like your normal distribution. Hold up. Let me get to this. Hold up. Give me a second. Give me a second. Let me bring up an image here. Actually, this is pretty relevant. So here's your normal distribution, and here's your fat tail distribution. So basically, this is pretty useful for you guys actually. So when you talk about normal distribution, this is what most people think of. And so fat tail. The reason why fat tails are interesting is because if you look at it, the sum underneath that distribution is still 1, but you at the tail ends of events that shouldn't happen, they happen a whole lot. They basically they don't happen as more. They just have a higher impact. So actually no, they say that's frequency of occurring here, whatever. But the point is that they have much higher impact here, and it's a lot more than what most people think. So wait, this isn't correct because like the frequency doesn't change; it's the impact that changes. Or is that the definition of black swan? I need to look that up again. But the point, you get my point here, is that basically, effectively, what the data here says, going for the increase in P50 time, but then the decrease in P99 times, is that you've gone from a fat tail distribution to a normal distribution where you've actually increased the amount of time up here. So instead of saying frequency, imagine this being time, or something like that. Anyway. I thought that was kind of interesting to point out. I think it's just trying to get that distribution done. Yeah, P50 grows and P59 shrinks. Right. So it's going backwards from the fat tails. But the thing is that in theory you shouldn't have to increase your P50 time in order to do that. So we want to see how this would impact real-time traffic onto the ad hoc and scheduled clusters. We roll out 365 to 1 instance over the production clusters over the course of the week. We monitored and looked at for regression, blah blah blah. So it's like, okay, well, there's a significant amount of performance regression that warranted looking things up. Okay, so this is how they troubleshoot things. Look for the default config changes. Yep, subtle cause regressions because they're not explicitly documented in the release notes. Interesting to note, the default stuff. Hive loader had concurrency of its changed from 4 to 64. Although changing it back improved the situation, we still found that we had a regression. Yeah, because you split jobs up, you spend more time splitting jobs up than actually running those jobs. Because for for the tail end stuff, you have more, those things run longer, so and it's a lot heavier, so you end up with getting more benefit from the 64. That's fine. So let's see how they see the other performance regressions. So we use a simplified query to find any large increase in wall time between 59 and 64. Okay. Increased time by 2x between 59 and 64 when we ran it ourselves. We expect the query on each version to find the culprit. By trying to release each release individually, we found the regression to be part of version 360. Okay. So they tried each release one by one, and then you ran on a profiler. Sure. Holy shit. Okay. So it looks like the cause of the regression was actually the CPU usage. Cool. This commit was identified as lifting as a potential issue because the trigger update call that was introduced was synchronized. Okay, yes, that's fine. Yes, we slowed down scheduler and added splits for processing. Okay. You reverted the change. Wait a minute. That sounds really. That sounds dangerous because if it's synchronized, it's synchronized for a reason because you have multiple threads. Schedule update, trigger update. So okay. If this needs to be updated, then you trigger your updates. Okay, so all these updates that would be triggered is all synchronized. Yeah, this sounds really dangerous because I don't know the context. I think I'll go into this maybe later. But this sounds super dangerous because you have like all these scheduled updates versus trigger updates. Actually, no, because they're scheduled. They're scheduled because then they'll actually be synchronized based on the queue itself. Okay, so if it's depending on how the schedule update is actually being used. So okay, I understand why they reverted it. That's fine. We found that fixed regression. One of our engineers contributed a fix to the Trino community as released in version 370. Doesn't look like there's a conversation worth talking about. Yeah, this is pretty standard, I think. We used Trino's patch, so in 360. The slowdowns got better, but still persisted, which means there was another performance regression between 360 and 365. Tried to use a different strategy. Use a profile to determine 30-minute window for version bisected. Found that version 365 was worse, 80% worse for a 30-minute workload. The profile layer was generated again. They did just repeat the exact same steps. And then they looked at the filter request function. This new Java library. Just slow down the new library that was used. Okay. So they upgraded. They bumped up a version that affected the filter request function. Okay. Wait, hold up. How did you know it was the filter request function to begin with? That's interesting. How would this tell you that? I'm guessing that if you did a git blame, this was the most recent change to it. So I'm guessing that they looked at the filter request function. They saw, oh yeah, this is fucking up. Well, the last recent change to it in that range was this. So I'm guessing. So this is probably how they narrowed it down. So there's letter JW2, which introduced performance regression, blah blah blah. Okay, so there's a problem in the JWT that fucked it up. Oh, nice. They actually were able to actually fix this. Okay, fine. You fixed performance regression, sets new performance benchmark, and identified new release regressions and shipped it. We were grateful reaching this finish line and standing on another line. Yep. It should not be difficult to adopt new releases. Manual efforts would be reduced if not fully removed from our upgrade process, as there's already sufficient interoperability between libtrino, customized branches. One action we could take is to fully automate the branch merging and building process such that every new release can be easily merged to our branch, blah, blah, blah. Yeah, that's an idea. Early adopters of Trino potentially leverage data scale. Data infra is dedicated to furthering strength testing and performance testing, covering real-world scenarios, blah, blah, blah. We restructure our technical tools to be more generic in both internal and external, blah, blah, blah. We're considering releasing benchmark based on our data querying. If you're interested in joining, hiring. Okay. So I think the takeaway from all this is actually like the steps that they used to try and bisect the issues, especially when you're trying to track down a specific commit. I would recommend people actually try to understand a little bit of this, but more so the way they evaluate performance and they bisect things. I think that it's actually a very, very good thing to look at. And I'll actually link it in the chat. I think people should actually look at it on their own time. But I can say that there's probably a lesson or two that people can learn here. I think the incremental rollout is definitely a good one. I think also the bisecting and the logic behind it is also a good one as well. So if you guys have a chance, I think definitely is worth reading. Let's see what Hacker News says actually. What? No comment. Hacker News people who should be reading fucking technical blogs have nothing to say. Are you kidding me? I don't know. This is okay. Wait. Okay. No, I fucked up. It's 907 comments. I clicked on the wrong goddamn one. Wait. No. Wait. Did I click on one? Am I tripping? No. I'm not tripping. No comments. And then there's 900 comments on like a Twitter CEO firing. Oh my god. I don't know, man. This is kind of getting me upset. I feel like this is like easily the best thing that I've read all day, you know. So whatever. Fuck it. I'm gonna quit. So, all right. I'm gonna shut off the stream. So thank you all for indulging me, guys. I'll see y'all later. And thank you for joining me. Stream not tomorrow, but on Tuesday. Okay. To 8 p.m. Pacific Standard Time. Later, y'all.